experienced by Q naught. So if you go by the Coulomb's law formula, if we just take this, if we just bring this Q naught down here in the denominator of F, that means this is ratio of force and the charge. So this remains K and this remains Q by R square and of course R hat. That's your choice. You can make it vector form or take magnitude without vector. That's your choice for understanding. There's no problem. That means this is nothing but ratio of the force and the charge. Q naught, test charge. This is what we have. This is the value, what we call electric field, E. So that is also a vector because F by Q naught is going to be a vector. So this is the electric field. That means whenever this test charge, you are bringing this from infinity. By saying infinity, I mean to say this is my boundary of this charge. Suppose say I have my boundary like this. This test charge is having a boundary around surrounding like this, where the field, its influence can be experienced. So any point beyond this is infinity. So when you bring test charge from infinity towards the positive charge, test charge, then the force experienced by test charge, because both are positive, there will be repulsion. So force experienced by that test charge while moving it is actually electric field. Stronger the field, stronger will be the force, because force is in the numerator. Now with mathematics you understand why we are taking this to be unit, Q naught to be unit, because if Q naught is more, the field experience will be more. In other words, I'll give some example. This is a channel, public channel. I don't give some political example here, but please don't misunderstand me while explaining physics. I have no intention to put up my idea with some political views or some religious views. But sometime if I give example, please don't misunderstand me. I have no intention to hurt any community or any political party or anyone. Being a man of physics, I am totally apolitical. I am totally, I'll say, non-religious. So my examples in physics can be from any field of society, but meaning is only physics, nothing else. So for example, suppose say you have a big leader here, very renowned leader here, and you have somebody other renowned leader here. Now who will experience whose field? This experience, if this Q naught is stronger than Q, then when you talk about field, you claim here E, electric field, is the field of Q, not Q naught. You are talking about Q. So if Q is much bigger, then electric field experienced due to Q on Q naught will be less. But in other words, if you say the electric field, then your job would be to find out electric field of Q naught, not Q. The other way around. So we have to take care that this value remains minimum. So we take unit test charge. But it should not be 0 also, because we have to have some value to realize the electric field. That means F by Q naught, that is electric field, is equal to Q KQ R square. In vector notation you write like this. So in short, so far we have, without vector notation, for quick revision, we know for Coulomb's law we have F, I won't give vector right now, F is equal to K QQ naught by R square, and electric field E is equal to F by Q naught, that means Q naught has come this side, this becomes K Q by R square. So these are the two basic formulas of the three formulas. You have very clearly seen we are tracing one single formula, that is Coulomb's law, and from this we are finding everything. Right now I'd like to clarify the concept of potential in the same line, and that is also through Coulomb's law. Potential in junior classes, 11th and all, you have done potential. If I talk about potential, we have a very clear picture that we talk about energy. In 11th you call it mgh, mass into acceleration due to gravity into height, and you know it very well. In a 3-storied building, in the terrace of the 3-story, the potential energy will be higher, and on the ground floor, the potential energy will be minimum because of the height of the same object, because G remains almost same, and H will be different, and we get different potential energy. But the point comes, when you talk about potential in the terms of electrical field, see my steps. First I talked about force, then I talked about electrical field, and now I'm talking about potential. That means you have an electrical field in the surrounding of this positive charge all around. So fields are going like this, lines of force, we call them lines of force, going outwards, because another thing I must say, I'm showing arrow outwards because I have considered test charge to be positive. If test charge would have been taken as negative, then of course I won't have claimed the field lines are in negative outwards direction. But this is a concept, convention universally accepted, where we take always test charge as positive test charge, so that all positive charges shows a positive direction and all negative charges shows a direction of the lines of force going inward. Because if I take a negative charge here, the test charge will remain positive and it will be attracted, so direction will be this for negative charge. All lines of force will be in this direction. So that is just a convention, there is no hard and fast rule, but we maintain that tradition of taking test charge as a positive charge. Now the question comes that when you talk about, let me get rid of this because I need some space. Now when you talk about the potential, that means we talk about, see, the whole chapter will discuss in much details about potential, but this is the beginning where you are getting habituated with the concept of potential, electric potential with formula, mathematical notations. Now say I talk about potential. Potential is energy, and energy is work done, and work done in class 11th you have done force into distance, nothing but force into distance. And in this equation, when I write E is equal to F by Q naught is equal to KQ by R square, my basic formula, then you have a clear picture here that you talk about force. If I multiply this with the distance, go by dimensional concept. If I multiply this, this is whole equation, linear equation. If I multiply this term with distance, I have to multiply even here, and I have to multiply even here with R. Then I have done nothing. This is R. You can see here, this is R. In linear equation, when you multiply with 1, if this is also R, is equal to F into R, and this is also R, so this cancels. This becomes work done. So dimension of potential is work done by charge. Though this is magnitude is 1, but we count this in dimension. So we say work done by charge as the dimension. This is nothing but same as our potential V. Still now I'm talking about the physical equations only. Physical meaning is not interpreted yet, but this is what we have. Now let's take the whole matter in vector form. In vector form, I have a clear picture that E is a vector quantity. E is a vector quantity. So I can write here E in vector notation. E is equal to F is a vector quantity by Q naught is equal to K Q by R square and R hat, that is also vector. So whole equation is now vector quantity. If I am to multiply a distance, that should be also in a vector, so I give a dot product of this. So I have to make a dot product even here, and I have to make a dot product of this here. So r hat dot r, angle between r hat and r is 0, so this turns to r cos theta. R hat, magnitude of r hat, magnitude of r cos theta, and theta is 0 here, so that is 1, so you get only r square. And here you get fr cos theta. In 11th you have done in work power energy. If you have in work done, if you have angle, you can go for 90 degree, you can go for 0 degree or any other angle, so you can dictate all by angles. Now why my main interest is this in this topic. This is equal to potential, we already claimed, and which is of course a scalar quantity. They do ask 1 mark question that potential, scalar, vector, and all these critical questions they can ask you, so you should be very clear. So this is what we have, the scalar quantity. So if we talk about this, then we have r. So I can let me concentrate to this only. The rest of the things you can see later. And but one thing, let me make it clear. Here you can consider this to be r q r, because r cancels, and you got rid of r because this becomes 1. Magnitude of this becomes 1. I think so. I don't elaborate this. You see my lectures on mathematical tools. It will be further more clear. If you have doubt, if you come across doubt, what I have done in this, how this r and r is getting cancelled. Now this is of course in, let's consider 0 degree. F and r also has got a distance of 0, angle of 0 degree. So this becomes only fr by q. I have no problem with this. Problem can be v is equal to E dot r, can be elaborately written as er cos theta. Now which theta we are talking about? What is the angle? Suppose say you have your distance to be, your charge to be this q. This is my q, suppose say. This is my q whose field I want to find out, and this field is E. So all lines of forces are the repulsive force for the test charge, they are going out like this. And this is my boundary where I have the test charge plus q naught, and it faces the electric field E because of this. And now I am talking about the potential V. So this is my another field coming in this direction, and this charge, I'll change color and show you, that will make you understand much better. So the test charge is moving in this direction. In this condition, E is in the blue and R is in red. So what is angle between E and R? In this case, it is 180. So 180 degree cos 180 will make it minus 1. So if it is equal to 180 degree, so it will turn to minus ER, minus of ER. So V will turn to minus of ER. If so, if V is turning to minus of ER, that means you are talking about some potential which is in minus of this. This is one of the crucial concepts we'll discuss as well, potential gradient, or we'll discuss in equipotential surface also, same topic. How come this is coming as minus? That means when you take the test charge which is positive in nature towards the electric field, towards the main charge whose electric field is experienced by the test charge, then we have a minus sign by default in this. So this concept should be understood very nicely. So ultimately we come with 3 conclusions. First we have done with Coulomb's law, which is this, and second we have done Coulomb's law, and that is leading to electric field, and third we have potential, so that is equal to E dot R or ER you call it, and that is equal to KQ by R, because R gets cancelled, so you are left with 1R. These 3 formulas are the basis of first 2 chapters. First 2 equations are used in first chapter, and this equation is discussed in second chapter, potential. So we'll discuss further about this chapter in details in our next coming